Hi, we're doing section 4.5 integration by substitution, and the first part of the notes is we're going to look at two methods, one called pattern recognition and the other method, method 2, which will be another video, will be on substitution. The benefits of pattern recognition is that it's very, very fast. The downfalls is you may not always see the pattern, and to be honest with you, sometimes it doesn't work. And so the other method, which is our substitution method, is going to have some advantages dealing with that. Make sure I have a pen. The idea behind this is if I have f of x, and f of x is equal to 2x squared plus 1, that quantity to the 15th power, and I want to take the derivative of it, I can invoke something called the chain rule, which means I'm going to go ahead and do the power rule here, which means I'm going to take that 15 and multiply it by the coefficient out front. My quantity is going to stay the same. I'm going to subtract 1 from 15 to get 14, and then I'm going to take the derivative of the inside and get 4x. So that's my derivative, and if I were to integrate that derivative, in other words, I have I'm going to integrate or find the antiderivative of 2x squared plus 1 to the 14th power times 4x dx. If you take a look right here, this right here is the chain that comes from what's inside here. And so I would treat this 2x squared plus 1, I'd write that as a quantity, and then I'd look at this exponent, and I would add 1 to that and get 15, and then I'd multiply or divide by 15 or multiply by 1 over 15, and I excuse me, and I would get an exponent of 1 right here, and then I'd have my plus c. And this chain disappears because it was part of the derivative. And if I'd go back through and take this derivative, I would get this value again. So that's the process that we're going to make. And so if I take a look at this, here's my quantity, this x squared plus 4. Its derivative is 2x. So the chain exists here. So I'm going to write x squared plus 4. I'm going to write that quantity. I'm going to add 1 to 1/3 and get 4/3. And then over here I have a coefficient of 1, and I'm going to multiply by the reciprocal of 4/3, which is 3/4. I'm going to add my c, because it is an antiderivative, and I'm going to end up getting 3/8 times the quantity x squared plus 4 raised to the 4/3 power. So if I were to forgot my plus c. If I were to take the derivative of this, the c would go to 0. I would take 4/3 times 3/8. That would give me 4/8 or 1/2. And then I would subtract 1 from this and I'd bring it down to 1/3. And then I'd use my chain and I'd have 2x. And I'd have that 2x times that 1/2, and I'd be left with x. Or I'd get that particular type of form. Alright, so same thing. I'm going to look inside this quantity. Its derivative exists, so the chain exists. So again, I'm going to just write x squared plus 4. I'm going to raise it to the 3rd power, multiply by its reciprocal, and add c, and I'm done. Again, on number 3, I look inside the quantity, see what its derivative is. It's a negative 4x, which exists right here. So the chain exists, so I write down the quantity, add 1 to the exponent, which in this case would be 4, multiply by the reciprocal, which is 1/4, add c. This is a little trick here. I'm going to put parentheses around the 5x. Again, I go to the parentheses. I look to see what its derivative is. It's 5. So the chain exists. So I'm going to figure out the antiderivative of cosine, which is sine, of 5x plus c. I'm done. This one's a little trickier. I'm going to give myself some room right here. Write this here. Integrate x 4x squared plus 320 squared dx. If I take the derivative of this, again, here's my quantity. If I take the derivative of this, I'm going to get 8x. I don't have 8x, I have x, but I don't have 8x, so I'm going to multiply by 8. And out here I'm going to write the reciprocal 1/8, because 8 times 1/8 is 1. So I'm really multiplying this whole integral by 1, and I'm not changing its value. Now I can just look at this right here, just this portion. And I'm going to see that its chain exists. So I'm going to have 4x squared plus 3. What's inside those parentheses? I'm going to raise it to the third power and multiply by the reciprocal. But lo and behold, I still have this 1/8 now, this part right here. And now I'm going to include plus c. So my answer is 1/24 times 4x squared plus 3 raised to the third power plus c. Now, if I'm going to check here to see if I'm going to get what I initially had, which is this right here. If I would take the derivative, I would take 3 times 1/24 would give me 1/8. 4x squared plus 3 raised to the second times the chain 8x. Now notice this 1/8 and 8 will give me 1, and I'll be left with that x, which is what I have right here. So this is just a quick check to see if this answer is correct. Alright, now I'm going to do the same thing here. I'm going to first rewrite this. And I'm going to have 2x minus 1 raised to the 1/2 power dx. Here's what's inside parentheses. Its derivative is 2, and nowhere here do I have a 2. Even if I have a 2 here and a 1/2, I'd have a 2x here, of which it's not chained to anything inside the parentheses. So if I use this pattern recognition for number 6, I would have to say it's not possible, because I don't have a particular method by pattern recognition to solve. So we'll come back to this problem number 6 when we talk about on the next page substitution.